Welcome to arc length and numerical approximation. So note, sometimes when we fill in the arc length formula, the integral from a to b of the square root of 1 plus f prime of x squared dx. Sometimes when we fill this in, we get an integral that we do not know how to solve. When that happens, we use numerical approximation, numerical integration. So in this case, we use numerical integration. So for example, we are going to use Simpson's rule with n equals 4 to approximate the arc length of f of x equals cosine of x between x equals 0 and x equals pi. So just note, in this case, we have a is 0, our b is pi, our f of x is cosine of x, which means that our f prime of x is negative sine of x. So putting all of these together, we get that the arc length is equal to the definite integral from 0 to pi of the square root of 1 plus negative sine of x squared dx, better known as the definite integral from 0 to pi of the square root of 1 plus sine squared of x dx. This is an integral that I don't know how to solve. It doesn't fit U sub. It doesn't fit trig substitution. So this integral does not work with U substitution. Integration by parts. Trig identities. Or trig substitution. Trig substitution or partial fractions, I should say. Hence why we were asked to use Simpson's rule. So using Simpson's rule, just a quick reminder, the rule says that we do the integral from 0 to pi of the square root of 1 plus sine squared of x dx is approximately equal to, we have delta x over 3 times, we will do that square root of 1 plus sine squared of x, I'm going to call this g of x, plus 4, sorry, not g of x, g of 0. We do delta x over 3 times g of 0 plus 4 times g of 1, not 1, g of x1, which will be pi over 4 plus 2 times g of pi over 2 plus 4 times g of 3 pi over 4 plus g of pi. So here our delta x is pi minus 0 split over our 4 intervals, otherwise known as pi over 4. Hence why we did 0, pi over 4, pi over 2, 3 pi over 4 pi. So we get that this integral is approximately pi over 12 times g of 0 plus 4 times g of pi over 4 plus 2 times g of pi over 2 plus 4 times g of 3 pi over 4 plus g of pi. And then we plug in our values. So note here, I'm taking this square root of 1 plus sine squared of x to be my g of x. So if we go ahead and plug in those values, plugging in 0 to the square root of 1 plus sine squared x, we just get 1. So we are looking at pi over 12 times 1 plus 4 times. G of pi over 4 is about 1.2247. Then we have plus 2 times g of pi over 2, which is approximately 1.4142. Then we have plus 4 times g of 3 pi over 4. So plus 4 times 1.2247. And then plus g of pi, we just get 1 again. So putting all this together, we wind up getting, sorry about that, my screen needed an update. So again, we have our arc length is approximately pi over 12 times 1 plus 4 times about 1.2247 plus 2 times 1.4142 plus 4 times 1.2247 plus 1. Plugging that into a calculator, we get that our arc length is approximately 3.829 or 3.83. So this allows us to do an approximation for our arc length when we cannot do the integral just by hand using integration theory. Right, in the next videos, we are going to move on into surface area.